Core blockchain origin. Core, powered by Satoshi plus consensus, is the result of the dialectical clash of Bitcoin and Ethereum. Inspired by the principles of both blockchains, Core displays a deep appreciation for the history of the crypto ecosystem paired with an even greater excitement for Core's role in its future. However, before standing on the shoulders of the giants that came before, this post will look back on the path they have set. That journey all begins with the man to which Core's consensus mechanism owes both its name and influence: Bitcoin. In 2009, Satoshi Nakamoto carved scarcity out of the stone of abundance. Despite its enablement of infinite replicability, the internet could now have its own native currency on the blockchain, Bitcoin. Powered by code and governed by unchangeable laws guaranteed by mathematics, Bitcoin's creation represents a step change in the evolution of money. Historically, populations looked to physical laws to determine and govern the dominant currency. These laws or characteristics can be broken down into two camps: store of value characteristics and medium of exchange characteristics. Store of value characteristics include hardness, durability, sovereignty, and counterfeit resistance. Hardness, resistance to unpredictable supply increases. Durability, resistance to rot, wear, pressure, or deterioration. Sovereignty, resistance to confiscation and counterparty risk. Counterfeit resistance, resistance to misidentification or forgery. Medium of exchange characteristics include liquidity, fungibility, portability, and divisibility. Liquidity, units can be sold quickly at market price. Fungibility, units are mutually indistinguishable and interchangeable. Portability, units are easily transported across space. Divisibility, units can be easily subdivided or grouped, increasing sellability across scales. In order to be a functional form of money, a currency must be effective first as a store of value, then as a medium of exchange. Therefore, hardness, also called soundness, has historically been the most important characteristic for initial currency adoption, because the difficulty to produce an asset defines its scarcity and ability to retain value over time. Historically, the standard currency across all civilized societies became gold, the asset most difficult to produce while sufficiently maintaining the other essential monetary qualities. Although gold was the hardest asset throughout most of history, its utility as a store of value sacrificed some medium of exchange use cases. Most notably, gold lacks portability. Carrying gold around to pay for everyday goods is a practical non-starter. Therefore, banks were needed to provide portable credit while holding the gold. Although portability made payments easier, the sacrifice threatened sovereignty and soundness. The likelihood of confiscation and inflation rose. Over time, these threats became promises. Leaving the gold standard in favor of fiat currencies destroyed the foundational soundness principle. Additionally, globalization required the need for more intermediation to transact across distant spaces. As a result, a permissioned system replaced the self-sovereign system. Defying the trend towards permissioned access, the internet enabled informational self-sovereignty. By enabling the infinite replication of data, the internet effectively gave each individual permissionless information. However, this permissionless information was based on abundance, which is contrary to the hardness principle of effective currencies. Early payments on the internet actually increased the need for intermediaries. All online payments needed to be intermediated by a trusted third party that prevented double spending. Money could exist on the internet, but only as a tourist. With the invention of Bitcoin, the internet could finally have its own native currency. As the first truly digital monetary asset, Bitcoin returned to first principles by perfecting what gold could only approximate: absolute scarcity. Only 21 million Bitcoins will ever exist, meaning that Bitcoin is the hardest possible money. It is completely inflation resistant. At its heart, Bitcoin is the complementary synthesis of gold and the internet itself. In bringing the best physical characteristics of money to the digital realm, Bitcoin either matches or outperforms gold's effectiveness on all fronts. Portability was gold's most significant limitation and the reason for its ineffectiveness. Bitcoin, however, pairs gold's scarcity with the internet's portability. It ensures absolute scarcity and infinite portability. Whereas gold's portability shortcomings led to permission custodians and the sacrifice of financial self-sovereignty, Bitcoin needs no such trade-off. With Bitcoin, payments across any time or space could be permissionless and self-sovereign. Before Bitcoin, digital cash was an oxymoron. Cash payments had to be hand-to-hand, limited to the physical domain. Bitcoin fulfilled the vision of truly digital cash money by combining four core technologies: Proof of work. Bitcoin's consensus mechanism is the most secure and decentralized in the blockchain world. POW requires miners to use energy to validate transactions and secure the network. This energy usage functions as the skin in the game necessary to maintain the ledger's truthfulness and the currency's hardness. Distributed peer-to-peer network. Bitcoin's entire transaction history is preserved by each network participant, a node, checking each other's work. This process ensures censorship-resistant peer-to-peer transactions. Hashing. Bitcoin's trustless verification is ensured by irreversible hashing, a method of computer cryptography that transforms any stream of data into a dataset of fixed size, known as a hash. Digital signatures. Bitcoin's self-sovereignty relies on mathematically related elements called private keys, public keys, and signatures. Holding Bitcoin is holding its private key, which makes its owner self-sovereign. With the combination of these technologies, a new level of economic freedom is now possible. Trustless, peer-to-peer transactions across any distance and digital medium. In order to maintain its legitimacy and continue to gain users, Bitcoin needs to continue down money's evolutionary path, starting as a store of value. To ensure the storage of value across time, monetary first principles cannot be forgotten again. The Bitcoin community needs to prioritize security by focusing on maintaining its hard supply cap of 21 million Bitcoins. Decentralized security is non-negotiable. Nevertheless, blockchain use cases are not limited to Bitcoin's maximally secure and decentralized model. The Bitcoin network is a system of the sturdiest and most impregnable walls in the blockchain world. These walls are essential for crypto's legitimacy. However, not everyone needs to defend them. Ultimately, a wall is far more valuable if a glorious nation is behind its gates. The Bitcoin community is right to prioritize security and decentralization, yet their focus does limit BTC's speed, programmability, and overall scalability. Safedet Amos in the Bitcoin standard acknowledges, Bitcoin scaling will likely require the use of third-party intermediaries. Amos also quotes Hal Finney, the receiver of the first-ever Bitcoin transaction, who stated, Bitcoin itself cannot scale to have every single financial transaction in the world be broadcast to everyone and included in the blockchain. There needs to be a secondary level of payment systems which is lighter weight and more efficient. Thus, the next call to adventure was born, Ethereum. In order to scale blockchain use cases, Vitalik Buterin leveraged much of Bitcoin's design to create Ethereum, a decentralized virtual world computer. Whereas Bitcoin is purposefully limited to the simple verification of transactions, Ethereum's groundbreaking innovation is the combination of general-purpose computing with a decentralized blockchain. With Ethereum, blockchain technology can do much more than send and receive payments. It can operate as the value layer for the next stage of the internet. Differing from Bitcoin's simple scripting language, Ethereum is Turing complete, meaning it can solve any reasonable computational problem. Within the Ethereum virtual machine, EVM, you can write smart contracts that execute code of arbitrary complexity. This means that Ethereum is an existentialist blockchain. Outside of needing to listen to the network's rules, each participant gets to choose their own purpose and adventure. The freedom enabled by Ethereum's composability and interoperability has inspired a robust developer community. Very quickly, Ethereum became the platform for programming decentralized applications, dApps, which are smart contracts often accompanied by web user interfaces. These dApps are built on top of Ethereum's open, decentralized, interoperable peer-to-peer infrastructure, so when you build a dApp on Ethereum's EVM, you can instantly connect it to hundreds of other protocols that already exist as smart contracts. In the Ethereum community, this is known as money Legos. As the money Legos continue to stack, one thing becomes clear: crypto-economic systems like Ethereum are the next evolution of human mass coordination. From hunter-gathering tribes, to organized religions, to nation-states, and finally to digital protocols, humans have found increasingly scalable technologies for group coordination. If Bitcoin is an impregnable system of walls, Ethereum is a neo-nation. As with physical nation-states, Ethereum has laws, economies, and cultures. However, unlike many top-down nation-states, Ethereum users choose the network. The Ethereum virtual machine equally governs all agents, applications, and information with the goal of preserving identity, liberty, and ownership. The EVM rule set harnesses the chaotic web, finally allowing the Internet to have its own native, self-contained economic and cultural flywheel. An Internet-native civilization can and will be built on the blockchain. The starting point of any successful human network is peer-to-peer exchange. Bitcoin introduced peer-to-peer exchange natively to the Internet, and Ethereum expanded it with decentralized exchanges, DEX. Human exchange saves time, resulting in the division of labor as participants focus on their relative advantages. On Ethereum, different developers focused on lending and borrowing with Aave, stablecoin creation with MakerDAO, liquid exchanges with Uniswap, or other innovative crafts. The division of labor develops into a network of specialized participants. On Ethereum, the division of labor led to the development of a suite of specialized, interoperable, and decentralized financial applications. Specialized labor then creates more efficient tools. Better smart contracts enabled a resurgence in DAOs and superior dApps. Ultimately, better tools increase productivity and lead to prosperous golden ages like DeFi summer. Then, the cycle repeats. Economic developments like trustless derivatives and cultural developments like NFTs are born, shocking both the physical and digital worlds. The economic and cultural flywheel is a positive feedback loop. It reinforces the founding ethos behind Ethereum, which is predicated on building and scaling the blockchain. One of the most important ways to scale Ethereum is the development of third-party Layer 2 solutions. Some L2s like Polygon, Arbitrum, and Optimism are already speeding up transactions and lowering fees by essentially gathering transactions off-chain and settling them on-chain in one transaction instead of several. In addition to L2 construction, Ethereum's culture of building even affects its Layer 1. Changing the blockchain isn't easy, but Ethereum has received many upgrades. Ethereum's upgrades can even be used to compete with Bitcoin's unchanging features like the defining sound supply cap. One-upping Bitcoin's sound money, EIP 1559 places Ethereum on the road to become deflationary by burning a portion of each gas fee. The Ethereum community calls deflationary Ethereum ultrasound money. EIP 1559 was a significant change, but no change is as significant as the merge. When the Ethereum mainnet merges with the beacon chain, Ethereum's consensus mechanism will transfer from a modified version of Bitcoin's proof of work, POW, to proof of stake, POS. Whereas POW has miners use energy to create the chain's next block and secure the network, POS has an efficient alternative. For proof of stake, network guardians called validators prove ownership of a sufficiently high amount of the network's native tokens. Then, the network randomly selects an eligible validator to create the chain's next block. To incentivize honesty, the validator must stake their tokens as collateral that can be seized by the network in the case of bad behavior. For POS, validators replace POW miners as the network guardians. Also, staking replaces energy usage as skin in the game. Finally, random selection replaces competition as the selection mechanism. With these changes, the upgraded Ethereum blockchain known as ETH2 is expected to increase scalability and transaction speeds while reducing energy consumption. The Ethereum community awaits the merge with much anticipation as they see another major opportunity to build and scale the blockchain. Web3. Bitcoin's Big Bang and Ethereum's rapid expansion of blockchain use cases have unleashed a new form of idealism on the internet. One of the most important manifestations of crypto idealism is Web3, the prophesied internet renaissance that transfers ownership and value from centralized corporations back to the builders and users. In the early days of the internet, the web was a decentralized suite of open protocols. These protocols allowed for messages, websites, file transfers, and other basic functions. Since it was decentralized and open source, Web 1 set the foundational rules of the internet. With the rules baked into the protocols, builders and users could interact directly without fear of the protocols changing, censoring, or exploiting them. Web 1 was a pure foundation, but it was also incredibly limited. Bugs were everywhere, protocols couldn't recognize user data, standard functions like search and commerce weren't yet available, and the whole thing was simply way too technical for most people. On top of that, this model had no incentives for further development because these protocols didn't make any money. By collecting and monetizing data and attention, Web 2 companies were economically and technologically enabled to build smarter protocols wrapped in accessible user interfaces. Problematically, however, the monetization method that inspired the Web 2 revolution also sowed the seeds of its corruption. At first, Web 2 improved the internet experience by bringing everyone together on the same platforms with attractive offerings. By locking in users, builders, and companies, these platforms achieved advantageous network effects. With these network effects locking in participants, Web 2 platforms were free to change the rules of the game. Web 2 transformed into a bastion of extraction as platforms began monetizing everyone's data and attention. As the holders of data and attention, platforms became expensive intermediaries between builders and users, artists and fans, companies and consumer data, and other relationships that used to be peer-to-peer. Just as self-sovereign money was lost with the transition from gold to fiat, self-sovereign identity was lost with the transition from Web 1 to Web 2. With Web 2, you do not own your own data. You, like money on the internet before Bitcoin, are only a tourist. Thankfully, as has been explored, self-sovereignty is a core superpower of blockchain technology. Bitcoin established internet-native property rights. Then, Ethereum expanded those rights on its decentralized platform with an economic and cultural flywheel. As previously stated, an internet-native civilization can and will be built on the blockchain. This is Web 3. The decentralization, openness, and community governance of Web 3 is reminiscent of Web 1. However, where Web 1 lacked the incentives for further development, Web 3 has rewards for builders baked into the code. With tokenized protocols, Web 3 can replace extractive intermediaries with community-governed algorithms. Without centralized, extractive middlemen changing the rules, network participants can truly, trustlessly, and provably own their data and money wherever they travel on the internet. If Web 3 is to become reality, decentralized and trustless crypto infrastructure must be at its core. Recently, however, the ideals of Web 3 have come under questioning. Notably, Jack Dorsey tweeted this on December 20, 2021. Unfortunately, Jack may be onto something. Since Bitcoin's beginning, crypto has trended towards more centralization. Particularly, Ethereum's POS transition comes with some significant costs. POS favors large ETH holders at the expense of decentralization and security. Large custodians, like Binance and Kraken, will have an outsized representation in the consensus process after the shift to POS given their increasingly large deposit bases. BTC proponents in particular cringe at the thought of centralization. They fear that POS places the Ethereum neo-nation on the same path as many of the physical nations that preceded it. Centralization, inequality, and, ultimately, unjust restrictions on freedom. Without a secure and decentralized network of walls, nations are susceptible to swift and malicious takeovers. Despite the BTC community's criticisms of ETH's transition, POS proponents view the merge as another opportunity to build, grow, and scale the ETH ecosystem. Less energy, faster speeds, more transactions, more dApps. Molded by a fast-moving history of building, ETH advocates want to expand the Ethereum neo-nation to new heights. To them, they already have sufficient security. Now, it's time to keep building. Despite tensions between BTC and ETH advocates, both communities can be correct. Ultimately, the core tenets of both BTC and ETH must merge to form a more holistic substrate for the future of the internet. However, these distinct systems can never form one singular body. BTC and ETH must retain individual sovereignty to remain legitimate. But just because the two blockchains can't themselves merge doesn't mean that the underlying designs and philosophies can't either. If Web 3 is to be maximally decentralized, secure, and scalable, believers must yearn for a balanced blockchain at its core. Crypto's history follows a pattern. First, a rudimentary, yet pure development kindles a fire of innovation. Then, in order to scale development pragmatically, compromises are made. That is, until those compromises are no longer necessary. Eventually, a solution arises, synthesizing the purity of the former with the practicality of the latter. Purity, then compromise, until finally a synthesis. Gold, then fiat, until Bitcoin. Web 1, then Web 2, until Web 3. Now, the next iteration of this pattern is here. Bitcoin, then Ethereum, until Core. Once again, Bitcoin is the system of the sturdiest and most impregnable walls in the blockchain world, and Ethereum is presently the most flourishing neo-nation. Core places the innovative Ethereum neo-nation within Bitcoin's secure walls. To boot, this metaphor actually does not go far enough. Despite being indispensable, walls can sometimes be viewed as peripheral protection. For blockchains, security is anything but peripheral. For core purposes, Bitcoin functions more like fire, the original energy network of the human race. With Bitcoin's creation, Satoshi Nakamoto successfully kindled an eternal flame. Since this pure process cannot be repeated, Bitcoin possesses unique advantages as a security-providing energy source. If the blockchain world wants to remain inextinguishable, Bitcoin must power its security. Recognizing the difficulty of stoking Bitcoin's eternal embers, Core employs a new consensus algorithm to scale Bitcoin's fire to new heights, functions, and use cases. Satoshi plus consensus will empower Core to unite the cornerstones of crypto by combining the security, soundness and decentralization of Bitcoin with the scalability and interoperability of Ethereum. The result is a Turing-complete, EVM-compatible blockchain validated by Bitcoin mining hash power, all operating at the core of Web 3. Core resources, website, docs, Twitter, Discord.